Hey guys, Jake here, coming at you with another math problem today. Here's the problem we're going to be going over today. We're going to take the integral from negative infinity to 0 of e to the x dx. So this is a good example of an improper integral because we have negative infinity as the lower bound of this integral. And we're going to do this using a method that's actually shown on my Calculus 2 study guide. There's a link down in the description where you can check that out. It's got all the formulas you need to go through homework and study for tests for a Calculus 2 class. An integral calculus class. So go check that out. Link is down in the description. But the idea here is we're going to be evaluating this improper integral. And the reason that we need to use this method is it doesn't really make sense to have infinity or negative infinity as bounds of an integral, because when you integrate a function and then evaluate over the bounds, essentially what you're doing is plugging those bounds into your function. And it doesn't really make sense to plug infinity or negative infinity into a function because they're not numbers. Infinity is just an idea of some really, infinitely large thing. But it's not a number that you can actually plug in. So what we want to do is instead rewrite this integral as the limit as t goes to negative infinity of the integral from t to 0 of e to the x dx. And the reason why we want to do this is it actually makes sense to plug in t and 0 into a function. So it actually makes sense now to use these bounds to plug into our integral. And then we can take the limit as t goes to negative infinity. And this will behave exactly how this integral does. So to do that, what we want to do first is integrate this function. Well, the integral of e to the x is just e to the x. And then we need to evaluate it from our lower bound of t to our upper bound of 0. And then don't forget, we're going to be taking the limit as t goes to negative infinity. After we do that, so to evaluate at these bounds here, we're just going to plug in 0 for x and then plug in t for x. So doing that is going to give us the limit as t goes to negative infinity. Plugging in 0 for x is just going to be e to the 0, which is just 1. And then we're going to subtract, plugging in t for x is just going to be e to the t. So now let's think about what happens to this function here as t goes to negative infinity. Well, as t goes to negative infinity, this piece here is going to go to e to the negative infinity, right? Well, e to the negative infinity, e to an infinitely large negative power is going to be the same as 1 over e to the infinity. And again, it doesn't really make sense to plug in infinity, but basically what we're going to get here is some constant, 1, over an infinitely large number. This e, this denominator here is going to go off to infinity. So if we have 1 divided by an infinitely large number, that fraction as a whole is going to go to 0. So basically this term here is going to go to 0 as t goes to negative infinity. So as t goes to negative infinity, we're just going to get 1 minus 0, which is just 1. So again, this method is on my Calculus 2 study guide. There's a link down in the description so you can check that out. It should be a huge help to you working through homework problems and studying for tests. Hopefully you found this video helpful. Thanks and see you next time.